Hey guys, in this video I'm going to go over my project of mounting a high-speed camera to the hub of the lawnmower we used for will and mow in an attempt to get some really interesting high-speed shots with the camera actually spinning with the mower blade. So there's no way this would survive spinning at the full speed of 3000 RPM, so I'm planning to run the mower at about half speed. That'll result in about 180 Gs or so at the tip of the camera, or edge of the camera, which I think is going to be survivable. The basic plan here is going to be remove the existing blade. I'm going to take a chunk out of this large 7-inch diameter piece of steel, about that thick. That will be machined so it can be mounted in the center here, and then there will be a replacement blade. There's going to be a single blade because I want the camera to see everything. I don't want there to be a blade on the other side where we don't have a camera facing, so the blade's going to be mounted sort of like this, ending about here, and then the camera will be mounted on top of this steel block at a slight angle by some plates. The idea of having the steel block at the center is to provide a large amount of inertia so that the whole assembly doesn't change speed too fast, so we don't shock the camera too badly. I'm not sure if this is going to work. I'm doing this with a camera built out of old production scrap, so this is not sellable, but it is basically functional. There might be some issues with it, but it's enough to test this. Here we go, that took about half an hour, I think. That's somewhat warm, but it came out pretty well. So that wasn't quite as good a cut as I was hoping for, but it seems to work. Now we can start by facing this off, and then we can drill a hole and machine the center to fit onto the lawnmower hub. All the turning is done now. This seems to fit just fine. So the next step is going to be to mill a slot across this for the blade to fit in. I'm going to try a little bit lighter cut on that because it was starting to chatter there. perfect fit. Look at that. So next is going to be cutting off this end of the blade. This one is at the correct length to match the original lawnmower blade. I'm going to cut this off and weld on a counterweight to balance the whole system out. To balance this, I've just set this up on a scale with a pivot point on the rotational axis. So if I just push down on this end, the scale will register how much weight we need to add to achieve balance. So this is about 420 grams. So we just need to cut a piece of metal that's that weight and weld it on the end. So because the metal is going to be a little bit farther out, 420 grams is a little bit too heavy, but we'll just leave it that way and then grind it down later to achieve final balance. The camera is going to mount on two vertical plates made out of this 3-inch wide by 1/4-inch thick aluminum. So go vertically. There's this pattern I've printed out that has all the hole positions needed. So I'm just going to glue that on, punch the holes, and then drill them. And I'll do the same thing with the other side, which is much more complicated in order to have room for all of the connections that go to the camera. Camera mounting plates are all done now. Last thing left to do is bolt this onto the frame, or to the flywheel. My initial plan to balance this was to basically move the camera around until it was balanced. The only problem is, actually, I'll show you what I'm doing to actually measure the balance. I've just cut this piece that has a very small little nub in the middle, and that sits on this flat plate, so this can sort of wobble around a little bit about its center. And if it's balanced, it should just sort of sit and not want to fall over one way. This one's a little bit off, but not too bad. Yes, my plan was to just put the camera on and move it around till it was balanced. The problem is, it has to be so far over for that to work that it's off, the edge goes off. So I'm only going to balance it approximately forward and back. The side to side, it will obviously be quite far off. Then I'll just fix that later by bolting on a weight somewhere. Balanced rather precariously on the edge here. I've determined how much weight needs to be added to balance it in sort of this axis, left-right. I'll cut a proper piece of metal, bolt that on, then we'll do the final balance forwards and backwards. I believe it will take only a pretty small amount of weight added up on the front to do that. Okay, so all the balancing is done now, at least theoretically. According to the little jig I made, it's balanced as best as I can get it. And I've had to add a few washers here to add some more weight to the front, so this is all set up on the mower. Let's give this a spin and see what it does. That looks so weird. If this works, it's going to get some amazing shots. So far, so good. Little bit of vibration. Oh yeah. Yeah, that's going to need some more balancing. I'm probably going to have to make a different jig to do this. The one I made before is just not accurate enough. So I decided to have another go with the old balancing rig because it would be a lot of effort to make a new one. And so to balancing it this way, I reset this up with a level, and that one is as good as well balanced as is possible as I can measure on this. Then I set it the other way. I've put a piece here so that it's held steady in this rotation, but it is free to rotate this way. And now I have set this up so it's fully level, the end of the blade on a scale, and there's definitely some unbalance because this is falling down this way. And experimenting around, I've found this bearing placed here causes this scale to drop down to pretty much zero. So I just need to figure out what this weighs and remove this much weight from here. So let's see how that does. Okay, that is now done. Let's see if this is any better. I might have to build that full balancing jig, or just throw some weights on it from the bottom so the mower doesn't move around for initial testing. Okay, let's try here. You ready? Yep. Yeah, we gotta fix that balance problem, but let's see what the video looks like. So that first test shot went pretty well, however there's still a balance problem, and I think this might be a static versus dynamic balance situation. So what I've done is that the camera has a heavy battery on this side, but we couldn't offset the whole camera to properly put it at the center of gravity, so I added this weight over here. I was thinking about this initially while mounting this, but yeah, I mounted the weight on the bottom just because it was really easy to do. But the problem is this creates a situation where it's statically balanced, hi Trixie, but not dynamically balanced. So what happens is basically both of these, the weight of the battery and the weight of this weight, generates centripetal force straight out, and you get a situation like this. So as this central shaft turns, these two weights are they're statically balanced. So this whole system comes out as balanced maybe when you just measure it normally, but when it starts spinning, you get centripetal force pulling these weights out, and this causes a torque in the center, which causes the vibration, because this torque is constantly changing in angle as this spins. So I'll correct that by moving this weight up to over here somewhere, so it's more in line with where the battery is, and we'll see how that does. Okay, another try after fixing the balance. Hopefully this will work better this time. Oh yeah, that's so much better. That is like completely smooth now. It's almost better than the original blade. For these demo shots you're about to see, I'm doing a few new things. I've got DSLR lenses on the Chronos cameras instead of the C-mount lenses. These will offer much sharper images. We're also running a beta software that can save DNG directly, that's raw, so the quality should be somewhat better. I've got this on the top. This is just a cage that mounts a 2.5-inch SSDs that allows DNG to save much faster. And unfortunately, after taking all these shots, I noticed there was a firmware bug in this beta software we're running. There's an off-by-1 error in the column gain correction, which causes these slight vertical lines to be visible in the video, so I apologize for that. But let's check out mower cam. Aw, little buddy, we hardly knew ye. Anyway, I think that was quite a success. We did not break the camera. There is quite a mess around the chamber. Be sure to check out Will It Mow to see more videos like this. Anyway, hope you liked that video. Thanks for watching.